This is the colligative properties of ionic solutions in the textbook. So up until now, all the problems that we have been doing have been molecular solutions, meaning the fact that they're all nonmetals. And molecular solutions are different because of the fact that they don't form ions in solutions. However, because of the fact that it's basically the number of particles in solution, if I have an ionic solution, I have to take that into account. What that means is if I have the same concentration of Ki and magnesium chloride in solution, magnesium chloride has 3 particles. So what does that mean? That means that when I form ions, if I take magnesium chloride and I put it into water, I go and I form 1 magnesium plus 2 chlorides. So the 1 plus 2 gives me 3. Okay? Versus if I look at the Ki and I put it into water, I form a K plus, this is a 2 plus, a minus, plus an I minus. So I have 1 plus 1 is equal to 2. And so because this is higher than all the colligative properties, I can't spell colligative, are higher. So that's why they tend to use magnesium chloride instead of sodium chloride as what we call rock salt, because of the fact that for the same amount of salt that you put down, you get a greater decrease in the freezing point and the boiling point. Okay, so magnesium chloride will have the lowest freezing point, it'll have the highest osmotic pressure and the highest boiling point, okay, and the highest change in vapor pressure. Okay, so all I'm doing is forming an I to each one of these equations. I tend to put it at the end. The book puts it at the beginning, okay, but it means the same thing. So let's look at this problem. It says arrange the following aqueous solutions in order of decreasing freezing point. Okay, so I have 0. Well, first of all, the formula is going to be the fact that delta TF is Kf Cm I. Like I said, I tend to put the I at the end. Okay, and Kf for water is going to be the same for this. So what I can basically say is that the delta T is going to be equal to Cm times I. All right. So if I take sodium phosphate, okay, some of you are going to say the fact that there are 8 particles there. There's not. You have to go back to knowing what your ions are. Phosphate is a polyatomic ion, and so as such, you have to treat it as 1. So this forms 3 sodiums and 1 phosphate. So that's I is equal to 4. So Cm times I is going to be that 0.10, the molality, times 4 to give me 0.4. I'm going to do the same thing for the sodium chloride, NaCl. When I break that into ions, I get Na plus Cl minus. That means that my I is equal to 2. So I have the concentration of 0.35, which is coming from up here, times the 2, gives me 0.70. Magnesium chloride, I just showed you that one, but that's okay. It's 1 magnesium plus 2 chlorides, so my I is equal to 3. So that's going to be equal to the 0.20 times 3, gives me 0.60. And anything that's these two here, this is all nonmetals. So therefore, the C6H12O6 is molecular. So I is equal to 1. So I take 0.15 times 1, gives me 0.15. And same thing is true for the methanol. It's CH3COOH. It's also molecular. So I is equal to 1. So it's going to be 0.15 times 1. Okay. So since this is a freezing point depression, okay, that means that the lowest number here, so this is freezing point depression, so the lowest number here is going to lower the temperature the least, okay? And so from high to low, that means that my C6H12O6, O6 is going to equal my CH3COOH, so the order didn't matter there because those are equal. So I've scratched out those two. Now the next one between those two is the sodium phosphate, so that's going to be greater than the Na3PO4. And I scratched out that one. Between those two then, that's going to be greater than the magnesium chloride. And that's going to be greater than the sodium chloride. So this is the order from high to low of the freezing points for this problem. Okay? And that is the end of this video.